Hello everyone, this is the beam design question number 2. This question is very similar to the question that we have solved in the first one, but one little difference, we will have a different design moment which will change everything, which is equal to 220 kilonewton meter, which is different actually than the design moment given in the first question. Other than that, just let's cover the given parameters very briefly. The base width and the D, which is the distance from the top of the concrete fiber to the center of the steel layer, is 270 millimeter. Base width is 1000 millimeter. Again, we are using C20 and S420 steel. The design concrete strength is 30 megapascals and the yield design strength of steel is 365 megapascals. As I said, we have a different design moment, which is equal to 220 kilonewton meter. The KL and KM combination for the C20 and S420 material combination is given like this. As I said in the first question, also in the lecture notes, the KL and KM is different for different combination of the concrete and steel materials. Again, you can also go to the tables that I have provided in the lecture notes and check it by yourself if you get the same answers for the KL and KM for C20 and S420 combination. Apart from that, the question is the same: design the beam and find the necessary steel area. So, as the first part, in order to understand if we need single reinforcement or double reinforcement, we need to calculate our K value. So we have formulated our K value as BWD squared divided by the design moment. So BW is given as 1000 millimeter in this question. I'm directly putting that over here. D is provided as 270 millimeters. So 270 squared, and the design moment is 220 kilonewton meter. 220. I'm multiplying it with 10 over 3 to have the same units in the top and in the bottom. So when we did the calculation, we get a number of 331. So this is the K value for the given design moment and cross-section dimensions. So when we have the K value of 331, it is less than KL, which is 380, but at the same time it is greater than KM, which is 260. So if it was less than KM, then we would need to change and play with the dimensions of the cross sections. But this is not the case for this question, so we have a K value between the KL and KM. So it is not greater than KL as in the case of the first question, but our K falls between the KL and KM values. So what we need to do here is we need to recall from our memory that we need to use double reinforcement in this question. What we mean by double reinforcement? Well, it means we need to have steel reinforcement both in the tension zone and in the compression zone. So this is the meaning of the usage of double reinforcement. Let's start with getting the moment values for getting the steel layer number 1. I will name this tension steel as AS1 and the upper compression zone steel as the AS2. Apparently the compression steel that is required in this question will be smaller than the steel that is required in the tension zone. Okay, let's move on. Okay, as you may recall from our lecture notes, we first need to calculate the first moment, M1, which is required to calculate the steel area in the tension zone. So how do you calculate the M1? we have the formula as like this. As you may notice, the similarity between those is we're just flipping the k and m values, but in that case we're just putting the kl instead of the calculated k in that formula to get the m1 value. So m1 will be equal to then 1000 multiplied by the d squared 270 squared, and kl in this case was given to us as 380. I'm directly putting that into the equation, 380, and so the m1 value that we are looking for is 191.8 kilonewton meter. So this is the moment value that we are going to use for getting the steel area in the tension zone. And recall the formula for the steel area in the tension zone, which we have used in the first question. It is very simple. We are just putting M1 instead of MD in that case, which is we have calculated here, M1, and M1 divided by FYD times Z times D, and in that case M1 is 191.8 times 10 to the 6. I'm multiplying 10 by 10 to the 6 because to have the same values between, to have the same units between the top and the bottom, at the numerator and the denominator. Okay, so what was the FID? It was given to us